let's work on section 5.1 now. We're dealing with rational expressions. All they mean by a rational expression is P over Q. Anything that can be written P over Q, where P and Q are polynomials in this case, Q not equal to 0. Really, all you really need to remember here is that your denominator cannot equal 0. So if your denominator were x minus 3, you know that x could never be 3 because your denominator would be 0, and we know anytime our denominator is 0, if the numerator is not, then it's undefined. So a rational expression is any expression that can be written P over Q, where P is any polynomial, Q is any polynomial, but Q is not equal to 0. So let's just jump into a couple examples. Because I'm limited on my time with recording, I think we'll do the first 6 examples in one video, and then I'll jump ahead and finish up section 5.1 in a second video. So example 1 asks us to reduce, and they give us x squared minus 9 over x minus 3. Now again, they're just asking us to reduce. We can't solve, it's not set equal. So we need to go back to our factoring. And section 5.1 and chapter 5 in general is going to be big on factoring again. So factor until you can't factor anything else out. However, one little hint is always use the book as a guide. They give you x minus 3. So just thinking this route, if they give you x minus 3, they probably expect you to get an x minus 3 on top. That way they can cancel out. If not, then you're not really able to do anything. You're not able to reduce. So if we pull out an x minus 3, it just so happens they start us with an easy one. X squared minus 9, we have a perfect square minus perfect square. We're going right back to our special factor rules that we talked about. We'll be using mainly the perfect square rules, but we might get into some cube rules. So once you've factored out and you can't factor anything more, again, go all the way back in time. Do greatest common factor first. See if that works. If it doesn't, is there a rule that we can look at? Perfect square minus a perfect square. If not, maybe there's 4 terms and we find out that we're grouping. But the key is factor. Once you factor out as far as you can go, you can think of everything together as a quantity on the bottom. And we see the x minus 3's cancel out. And we are left with simply x plus 3. Okay? We're going to skip ahead a little bit and go to example 4. And example 4 asks us to reduce, and they give us x squared minus 3x plus ax minus 3a. So a pretty big chunk here that they give us. X squared minus ax minus 3x plus 3a on the bottom. Hopefully I wrote everything correctly. I will double check real quickly. Yep. So what happens here? Again, use the book. The book will guide you. They want you to do certain things, so they're steering you that way. When we have 4, probably going to group. Typically when they give us 4 terms, we're grouping. So we have an x squared and a 3x here. I can group, I can pull out an x. Now if I was doing this in class, I'd have plenty of different colored markers, but we didn't have time for that with the big quarantine going on, so we were kicked out without time to prepare. So I'm using a black marker for this one. So I'm going to pull out an x and see what I have left. Well, I have an x minus 3. Again, when we're talking grouping, we're pretty sure that we want an x minus 3 over here. To get an x minus 3, we're going to draw a positive a. When we do, we'd be left with an x and a minus 3. That's what we needed. We're going to do the same thing on the bottom. And we're, again, you might see that there's an x here and an x here, an a here and an a here, x and x. You can group differently, but just go with the first 2 and the second 2. That's how almost everyone, I can't say every, we don't want to use 100% words in mathematics, but generally what the book is wanting is the first 2 grouped and the second 2 grouped. So I'm going to draw out an x, and I'm left with an x minus a in this case. Now, again, I want an x minus a because then I would have a group and then I'd be able to draw it out. So to get an x minus a, that helps me, that helps determine if I'm subtracting or adding. I know I'm pulling a 3 out, no matter what. I know I'm factoring a 3 out, but whether or not it's a positive or a minus, a negative, I can use that as a guide. Then I don't have to change anything. To get a positive x that I need to match up here, I need to negate that. So I need to pull out a negative 3. And then I'd have a negative times a negative would be a positive 3a. So now I have my groups. I'm going to rewrite down below it before I cancel out. So up here, I have an x minus 3 in each group. I would be left with an x plus a. So if I pull out my x minus 3, I'm left with x plus a. Here, I have an x minus a that I'm going to factor out of the 2. I'm left with x minus 3. Now, they have to be exact. We're looking for exact quantities on the top and the bottom. Anything's fair game on the top with the bottom once they're multiplied, once we've factored all out and they're multiplied. So I have an x minus 3, and that matches up with an x minus 3. Here I have an x minus a, an x plus a. So those are different. Since those are different, my answer is x plus a, x minus a. Okay? Now I'm going to work to erase as cleanly and quickly as possible to finish this first group of examples. And I'll go to example 5. Actually, since we're videoing, you can pause, so I don't need to leave all this up. If you want to double check something, just rewind and pause it. Alright, so clean board. Example 5, they give us, almost trying to just trick us. Sometimes they'll give us something simple. They'll give us something simple, but they want to just trick us. I want to follow the way the book does it. You can draw a -1 out of either one of these. This is a positive a, here's a negative a, here's a negative e, positive. They're both opposite. Since both of these are opposite, I can just change one of them. The book chooses the numerator, I believe. So the book says, hey, let's factor out a -1 out of the top. If we factor a -1 out of the top, that would leave us with a negative a, positive b. Because I multiply that through, I'd have a positive a, negative b, that's what I have. But when I look at this, I multiply it by a -1, and I have my negative a and my positive b. The book probably cleans it up. Let me double check. No, I don't know. I don't think they even do. But you can think of this as quantities. I can just rewrite it. I have a b and a negative a. If you want, move things around to make sure you've got them the same so they cancel out. Those cancel out. I'm left with a -1 as an answer. That's why it's a -1. I only negate one of them. If I negate them both, then again they're going to be opposite. So I negate one, and I just made them the same. Alright, example 6 now. They give us, I'll go up here and then work down. They give us this. Well, step 1 is, this one's factored out, so I'm leaving it. But up here, I have a perfect square minus a perfect square, so very little effort involved. Not really anything to think about. I have x plus 5, x minus 5, all over 5 minus x. Again, that 5 minus x is darn close to x minus 5, but it's different. So I'm just going to make it the same. So what I am going to do is draw out a -1. I'm going to rewrite this in one step. I draw out a -1, that means I would be left with a positive x and a -5. So I factored out a -1 in the bottom. And then I just moved it to put my x first. Then on the top, I still have my x plus 5, x minus 5. Now I see what happens. Those go away. Since -1 is on in the denominator, I'm just saying it's the same thing. Divide it by or multiply it by, either one. You negate it. The book simply leaves the negative. I put a -1 in. The book will leave it as negative quantity x plus 5. I wrote it as -1 quantity x plus 5. Same thing. Let's stop there for now, and then I'll go to section 5.2 after this.